Hello everyone, I'm Christina, and in this video we're looking at question 10 of the Edexcel 2018 A-Level Mathematics Paper 1. Let's have a read through the question and then attempt part A. So the height above ground, h meters, of a passenger on a roller coaster can be modelled by the following differential equation, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride, show that h can be expressed as a function of t in this following form. So let's write some things down to help us. We have that there's an initial height of 5 meters at the start. So that's going to be when t is 0 seconds. What we can do here after we write our differential equation, because we want a function of h with respect to t, we can integrate by separation of variables. So how we do that is we can separate each variable onto opposite sides of the equal sign, and then we can integrate each side with respect to that variable only. So if we have a look at how we get from here to here, you can see that I moved this h onto the left-hand side. So the only h term on the right can be associated with the dh on the left. And then all that's left is this cos of 0.25t over 40. Well, that's all in terms of t, so I can just bring up dt onto the right-hand side. And so that way I've separated each side with its own variable. Now this 40 is a constant, so you could move it onto the left by multiplying through by 40, or you could have kept it in the denominator on the right-hand side, but it just looks a bit better if I bring it up, so we don't have a fraction on the right. So then from here, we can integrate. So on the left, what we're doing is we're integrating our expression with h, only in terms of h. And then on the right, we're integrating our expression in terms of t only with respect to t. So now let's continue. Let's continue the integration. So on the left, it might be easier to pull out the constant 40 and write it as 40 times the integral of 1 over h dh. And then on the right, there's no constant to pull out, so it's still cos of 0.25t dt. Now on the left, 1 over h, the integral of 1 over h dh, this becomes ln of h. And then, of course, the 40 at the front remains there. So 40 ln h equals, and now we have to integrate this cos term. So cos integrates to sine, and since it's cos of 0.25t, it integrates to sine of 0.25t. But then we need to adjust for the constant that we get out of what's inside the trig function. So I like to think of it as going backwards. So when we integrate cos, we get sine of 0.25t, but then what is the constant missing in front here? Let's think about working backwards and differentiating sine of 0.25t to get to our cos of 0.25t. When we do that, from what's inside the brackets, we get a factor of a quarter out. So actually ignore me writing it there, but if we actually differentiate it to get cos of 0.25t, we're also going to get a factor of 0.25 in front. However, we can see that there is no factor associated with cos of 0.25t, so there's no coefficient here. So then that must mean that when we differentiate sine of 0.25t, and we're expecting a factor of 0.25 in front, we must be multiplying by 4 to cancel it out. So we just get cos of 0.25t. So then we get 4 sine of 0.25t when we integrate, plus c. And what we can do from here is rearrange to make h the subject. So let's do that. Let's maybe divide through by 40. Alternatively, 40 ln h can be written as ln of h to the power of 40. Let's just have a look at the form that we expect our answer to be in, because that can give us a bit of a clue. Right, so we can see that we have e to the power of 0.1 sine 0.25t, so 0.1 sine. Well, if we do 4 divided by 40, we'll get a tenth, and that's 0.1. So in fact, from looking at our answer, it looks like it might be better to just divide through by 40 first. So let's do that. Ln of h equals 4 over 40. So that's a tenth sine of 0.25t plus c over 40. Well, c is just a constant. It's an unknown constant at the moment. We are going to use our boundary condition to find it, but a constant over 40, that's just another constant. So we can call it C1, because it's a new constant now, but it's still an unknown constant. Then we get ln of h on the left equals a tenth of sine 0.25t. So now from here, we just, again, our goal is to have h equals. But of course, we have ln h on the left. So what do we do to cancel that or undo that? We apply the inverse. So what we actually do is we apply our exponential function. So then both sides are raised to the power of e. Now, e ln of h is just h, because e is the inverse function of the natural log. The natural log is the inverse of the exponential. So then on the left, we get h. On the right, we get e to the power of, because we're raising all of that to the power of e, we get a tenth, let's write that as 0.1, sine of 0.25t, now plus c1. Now, if we add the exponents, that means we're multiplying by the same base raised to that constant. So this is the equivalent of this. And so we can write h equals e to the 0.1 sine of 0.25t times e to the power of c1. But e to the power of c1, that's e, which is a constant, to the power of c1, which is a constant. So this is another constant. We can call it constant a. And we typically write it before our exponential function here. So we can write it like that. So this is equivalent to this. So now is a good time for us to apply our boundary conditions. And our boundary conditions, as we initially wrote them down, h equals 5 when t equals 0. T equals 0. Therefore, 5 equals a e to the power of 0.1 sine of 0.25 times 0. So that's sine of 0. Well, sine of 0 is 0. And if this is 0, then 0 times 0.1 is also 0. So we get a times e to the power of 0. That 5 is still there. So 5 equals a times e to the 0. Whenever you raise any number to the power of 0, then that becomes 1. So then 5 is our constant value a. So a is 5. Now if we plug that in to our expression for h, we get h equals 5e to the 0.1 sine of 0.25 t. Let's have a look if that's what we got. And that's exactly what we needed to get. So that's how you would do part A.